Hello students, welcome to TechnoGATE online educational platform. Myself Prasanna Kumar, I have a teaching experience of around 9 years. I'm going to teach you engineering mechanics. I have passed out from IIT BHU Varanasi and we're going to start from very basics of engineering mechanics. The basics which you have studied in your 11th class, the basics which you have studied in your 9th class, and slowly will build up the level. So I welcome you all to this lecture series on engineering mechanics. Now let's start our subject with the classification of mechanics. So this mechanics first of all deals with solids, then we'll use the same mechanics while dealing with fluids. Fluids means it is adding up both, it is combined both liquids and also gases. Okay, so let me write down the classification and let's understand from that. Okay. So this mechanics deals with the two states of matter, in fact three states, but liquids and gases are combinedly called as fluids. That's the reason why it is given like this. So the mechanics which deals with solids, solid mechanics. The mechanics which deals with fluids, it's given the name as fluid mechanics. Okay, and in solid mechanics, first of all, we'll take an assumption. We assume that our body is a rigid body. Okay, so we assume the body to be a rigid body and then we will deal with that, and slowly we'll drop that assumption and take the body to be a deformable solid, and then we'll deal with that. So rigid body means basically the body which does not undergo any deformation at all. Fine. So whatever is the force which you apply, it will not undergo any deformation. So just for understanding purpose, I'll write down the definition here. So rigid body. So I'm writing down the definition here. No matter whatever is the force acting on the body, no deformation will happen. No deformation will happen. So while dealing with solid mechanics, first of all we'll learn or we'll apply this mechanics for a rigid body and then learn the concepts, and then we'll update by dropping the assumption that the body is a rigid body. Okay, because rigid bodies are not at all available on earth. They are imaginary, because you take any body, you apply some force, you take a stone and throw it below the wheel of a road roller, it will get crushed. So every body will undergo deformation at some value of load. So there is no perfect rigid body at all. Clear? That's the reason why we will drop the assumption later going through this concept here. So when you deal with solid mechanics with the assumption of rigid body, then it is called as rigid body mechanics. This is the first one here. Then we'll drop the assumption, it will become deformable solid mechanics. Deformable solid mechanics. Okay, so here in fluid mechanics you'll deal with liquids, then you'll deal with gases, sometimes you deal with liquids and gases combined, and so on like that. Okay, so here if you see, we'll go with rigid body mechanics and then we'll go with deformable solid mechanics here. So this rigid body mechanics subject is given the name of engineering mechanics. So whatever we're going to study in this subject is actually the rigid body mechanics. Okay, so this is our subject, engineering mechanics, and this subject is given the name as strength of materials or mechanics of materials. In our gate we have these titles here. So these are first subject and this will be our next subject or subsequent to engineering mechanics. I believe it is completely clear to you guys. So this is the classification of mechanics. So here we will be having subjects like fluid mechanics, and this will be giving rise to thermodynamics, because there will go with different states of matter, different temperatures, different volumes, different pressures, all those things and all. So we don't have to deal with that at this stage. Simply you should understand that in our subject we will be going with the assumption that the body is a rigid body. It's very, very important. Fine guys here? Okay. So now we are done with the classification of mechanics. So we got an idea what actually we are going to do. Now let's see the chapter names of this whole subject and start with the first chapter. So we already started the first chapter. Just to have an idea, let's understand what we are going to see in every chapter. So we have 6 chapters in engineering mechanics. First chapter is introduction. In this we are going to see all the basics from 9th class definitions like mass, weight, force, okay, momentum, all those things. From that level we are going to start. So we'll take all the basics in this, cover up everything, mass moment of inertia, area moment of inertia and everything, and then we will be going into very important concept called as equilibrium. Very important concept called as equilibrium. We'll apply this equilibrium concept in the concept called as trusses. We'll apply the concept of equilibrium in the concept called as trusses. Next chapter. Next, 4th chapter is friction. So you may be very familiar with this friction chapter, or you may not be very familiar, or you may be a little scared about it, because questions are a little complicated sometimes, and there is a very high chance that a tough question can come and you may end up not getting the answer. Okay, but we're going to start from basics. We'll understand everything, we'll solve every gate question, and once the chapter is over you will be able to tackle any type of gate question. Okay guys, so this is friction, and 5th one is kinematics. Okay, and the last one is given the name as kinetics, or it's having other name as dynamics. Okay, so in kinematics basically we deal with only the effects of forces, and in kinetics we'll deal with both forces and also effects of forces. So we'll understand the definition and everything in a more thorough way when we start these subjects. Okay, in gate examination, when you are preparing for gate examination, you will have question most probably from these 2 chapters. Okay, it doesn't mean that you will be, sorry, not this, it will be mostly from these 2 chapters here. It doesn't mean that other chapters are not important or like that. Okay, basically this chapter is having its basics in first 2 chapters. So if they ask a question here, automatically they can understand the level of clarity you have in the remaining 2 chapters as well. That's the reason why they put questions from here. And next one is this, because this makes the basement or a foundation in another way for the whole engineering mechanics, not only for engineering mechanics, whole civil engineering. That's the reason why it is given good importance, and mostly questions are asked there. And sometimes you can expect a question from here as well, friction as well. It's an independent concept. So we are going to start from basics and we'll slowly build up the level, and you will be able to tackle it very thoroughly. Okay guys, so now let's start with the first topic, or first topic definition, that is rigid body. So we have already discussed it. Let me just revise it and let me write down the definition, and then we'll go to the next topic. Okay, so the first topic is rigid body. So I told you that no matter whatever is the force acting on the body, it will not undergo any deformation, and we assume every body is a rigid body in the whole subject of engineering mechanics. Whether it is said in the question or whether it is not said in the question, you are going to consider the body to be a rigid body. Understand? And as we are considering the body to be rigid body, there will not be any deformation. So we are not at all concerned about any deformation in this subject. When you go to next subject, that is strength of materials, we will be dropping this assumption. So there we should be dealing with deformations, stresses and other things. Clear? So rigid body, no matter whatever is the force, So this is the definition of rigid body. So we'll take this assumption throughout this subject. Okay. Now let's go to the next term which we should know, that is nothing but mass. So what is mass basically? So you may have studied in chemistry that there are protons, electrons, atoms, molecules, all these things. So this is actually called as study of matter, M-A-T-T-E-R. So how much amount of matter is there inside the volume of a body is called as mass basically. So how much amount of matter is there, how much amount of electrons, how much amount of protons, how much amount of atoms, molecules, all those things are there inside a specific volume, that is called as mass. Amount of matter present inside the volume of a body is called as mass. Okay, so it is very simple definition. So this is what you have studied in your 9th class, and now also same definition. So no issue or no changes there in this definition. Okay, clear? Let's go with the next topic. Next topic is distance. So distance, very obviously known to you people. So the amount of length of the path you have traveled is called as distance. For example, this is your home and this is the TechnoGATE Institute. Okay, so from here, as there is no straight line or straight road from your home to TechnoGATE, you may have to go like this, like this, like this, going through all the turns, and you have to reach there. So the length of the whole path travel is given the name as distance. Understand? So length of the path traveled is called as distance. So simply take the path, measure it, and that's the value here. Simple, very simple. Going forward, displacement. So there is slight difference between distance and displacement, and very interesting. So displacement is basically, we are not concerned about how much length of the journey you did. Simply take the first point, simply take the last point and join both of them. Okay, so I am joining your home with the TechnoGATE Institute here. So there is a straight line like this. So this straight line will be having its length, okay, and this straight line will be having a direction as well. Okay, so this straight line which is joining from home to TechnoGATE is given the name as displacement. Clear? So this is, strictly speaking, shortest path between the 2 points, okay, and directed from first point to final point is called displacement, is called as displacement. It is called as displacement. Clear? So we have understood that this, in this diagram, this black colored line is distance and this blue colored line is actually displacement. Okay, so let's go forward with the next term that is given the name as speed. The speed is nothing but whatever this distance is there, you divide by time. So basically you're dividing by time means rate of change basically. Okay, so speed is equal to given by rate of change of, so speed is given as rate of change of distance is called as speed here. Next term is velocity. So in velocity everything is same as the previous definition, but only thing is it is not rate of change of distance, but it is rate of change of displacement. It is rate of change of displacement here. Okay, here you should understand one very crucial thing. When you are taking distance, simply it is the path. Okay, but when you are taking displacement, one extra thing is coming, that is basically direction. From where it is pointed, from first point to the last point. So the direction is very, very important here. Okay, understand? So when you are dealing with distance, when you are dealing with speed, so you are concerned with only magnitude. What is the quantity? Distance is from starting point to last point, right? So the length of the path traveled. So what is the length? That's all. Same with speed. You take the distance and divide by time. So these two are basically scalar quantities. To define these, only magnitude is required. Only magnitude is required. Hence these are scalar quantities. Hence these are scalar quantities. But whereas when you are dealing with the displacement and when you are dealing with velocity, when you are dealing with displacement and velocity, we have to define not only their magnitude, but we should tell their direction as well. So what is the direction which actually they are going? Okay, so to define these, we need not only magnitude, we need magnitude and also direction. Okay, so these type of quantities, I hope you people know that they are called as vector quantities. Clear? So these are called as, hence these are vector quantities. Hence these are vector quantities. Hence these are vector quantities here. Understood? So we have the speed and distance scalar quantities, displacement and velocity as vector quantities. Clear, guys? So now let's enter into the next topic. The next term is momentum. Okay, momentum. So momentum, you may be already knowing the definition. So if I ask you the question to you guys, immediately you will shout that it is, sir, mass into velocity, right? Okay, it's correct, nothing wrong in that. So let me write down the mathematical formula for this. So momentum, so it is defined by mass. So momentum m, or basically p, is equal to given by mass into velocity. As velocity is taken here, it should be a vector quantity. So momentum p is equal to given by mass into velocity here. But what is the significance? Why we are multiplying mass? Why we are multiplying velocity? Why can't we multiply something else? That's very important, right? So let's understand about this product of mass and velocity. Clear? So let me explain you by taking an example. Okay, let's assume you have a stone. Okay, you have a stone in your hand. That stone is of this much size. Okay, and you have another stone which is of little small size here. Okay, and you are throwing and hitting a wall or something. Okay, hitting a wall or anything. Okay, so hitting a wall or anything. So this mass is high, this mass is less. Okay, and you are releasing it with a velocity which is of something like 10 meters per second, but this is with a velocity of something like 50 meters per second here. Okay, and let's take mass also. So mass is equal to given by, let's take it as 5 kg, and this mass, let's take it as 1 kg. So larger mass, smaller velocity, smaller mass and larger velocity. Clear? So these two are thrown here. When you are throwing with these values of mass and velocity and hitting something, when these masses hit a surface, the amount of force produced will be same, because this momentum is the measure of force. So how much force is produced there, it is dependent on the momentum. Clear? So these two will give rise to same value of force. Okay, so momentum you should keep in mind. So momentum is measure of force. Momentum is a measure of force. Measure of force. Momentum is a measure of force basically. Clear? So in this one you have to understand that it is a measure of force. So if you have same values of mass and velocity, you will have same value of force. And how it is measured or how it is calculated, the value of force and all, so you are going to study in the coming concepts, but just now presently I will give you a basic idea. Okay, so it is given by Euler's method or given by Euler scientists basically. So momentum is equal to given by rate of momentum rate change. So d by dt of momentum change is actually given by force. Rate of change of momentum is equal to given by force. So that means, so rate of change of momentum is equal to force. So if you want to get the force corresponding to this F, so final momentum mv vector final minus mu vector initial whole by time. So you are hitting with these two stones and these will be going to a wall and hit. So this will hit and come to velocity is equal to 0 meters per second. Same, this small stone also hits and comes to velocity is equal to 0 meters per second. If velocity, the final velocity is 0 meters per second, what would be the momentum? If the final velocity is 0 meters per second, momentum would become 0, because velocity is 0, momentum will become 0 here, but initial momentum is same and time of collision whatever is occurring is also same. So you're going to have same value of force. So this is how you're going to measure the impact which is occurring there. Clear? So I'm just revising once again. So momentum is basically given by product of mass into velocity, and it is a quantity used to measure the value of force, and that is given by rate of change of its value, that's equal to the value of force. So you take the final momentum, you take the initial momentum, take the subtraction, divide by time, you will be getting the value of force. Clear guys? Now let's go into the next topic. It is given the name as particle or point body. Particle or point body basically. So particle or a point body means what? Actually, when the dimensions of a body is very small, if it is very small, then you don't have to take concepts which are related to dimensions, large dimensions like area moment of inertia, mass moment of inertia, torques, okay, and other things, radius of gyration which are related to that one and so on like that. So you can neglect all those complicated concepts and simply take that body only, and whatever the velocity, mass is there, simple these things you can consider them, that's it. Clear? So particle or a point body means its dimensions, it is defined like this, its dimensions are small, when compared to the distance traveled by it. So there should be some comparison, then only we can say something is small, something is large. So we'll tell with respect to the distance covered by it. Clear? So its dimensions are small when compared to the distance covered by it. Distance or displacement, you can use both the words here. distance covered by it. Okay, so when you consider the body as a particle, you don't have to consider complex concepts. Okay, so for a particle or a point body, we can neglect complex things like, so for a particle or a point body, we can neglect complex things like area moment of inertia. You'll understand what are all these things later. Mass moment of inertia, etc. Clear? So simply take whatever the total value of velocity is there, whatever the total value of mass is there, and you can deal with that one. Clear, guys? Okay.